Good afternoon. My name is Palo Pierce from Eduporium, and I'm pleased that you've joined our webinar today titled Pre-K to Sixth Grade Coding and Robotic Solutions. We're happy to have one of our strategic partners, Terrapin, here. And so we have Bill Glass, who is the president of Terrapin, will be attending and will be talking with us. And then also Luis Noriega. And both of them will give a great overview of the products that they feel and the coding solutions and robotic solutions for what I'll call elementary. What I wanted to do is take a second and just explain who Eduporium is. And let me just, I'm sorry. One of the things is Eduporium, our focus is to focus on educational STEM solutions and provide a one-stop for not only researching the products, but deciding what to put into your programs and things like that, your grants and things like that. So we have a wide variety of solutions, everything from coding robots to 3D printers for makerspace, laser printers, virtual reality and augmented reality, science kits, esports, electronics kits, and much more. And I think there's a couple things that really differentiate us. And one is we only focus on education. So we focus on K through 12, colleges, after schools, and libraries. We don't really focus and do much business at all with any type of commercial business. Our focus is educators. We do provide an educational discount where possible, and that's based on the manufacturers and things like that. In addition, we are a certified minority business enterprise. We are located in Newton, Massachusetts, which today is a balmy 53, 55 degrees, but in the winter it can get a little more colder. And we do work across the country and have done business in all 50 states. We predominantly focus in the United States. If you have any questions or anything like that, it's Palo at Eduporium, P-A-L-O, if you have any questions, or you can just contact sales@eduporium.com. And we look forward to talking with you. So with that, I'm going to hand it over to Luis and Bill, and they'll be taking us through their exciting products and a review of them. I appreciate that. So let me stop my share, and I think, Luis, you should be set.
Thank you, Bello. Okay, I'm going to share my screen so I can show you a PowerPoint. And Bill, I'm going to, okay, now I'm ready. Okay. Okay, Bill.
Yes. Thank you for joining us today. Luis and I are with Terrapin. Terrapin makes what we call tools for thinking, and we're going to show today the tools we have for pre-K to sixth grade. Terrapin has been around since 1979, and it was founded to publish the Logo programming language, the very first coding app for kids. You might not have known there were coding apps that long ago, but we published Logo and we've offered turtle robots. And now we have an entire line of interactive robots and coding tools throughout the curriculum. And today we're going to talk about the 3 robots that are targeted at pre-K to sixth grade: the B-Bot, the Blue-Bot, and the Tuff-Bot. And we'll start off first with B-Bot, which is targeted pre-K to second grade. B-Bot is a little robot that is controlled by the buttons that you see there on its back. It can go forward, back, left, and right. And it is a tremendous motivating device for children. They love to use it. And because they love to use it, they're willing to learn how. And by learning how, they learn sequencing, estimation, problem solving, coding, and computational thinking. And so they have to count, learn distances, estimation, and also many subject areas. Not only can you use B-Bot to teach coding, but it can be a motivator to teach a wide variety of subjects. And Terrapin offers a wide variety of accessories to support your use with B-Bot. including chargers so that you can keep them charged up. And then we have, if you see down on the left side, there are the jackets. You can turn Bee-Bot into another character by getting the designer jackets that fit over him that kids can decorate, put stickers on. An ideal way to use Bee-Bot to tell a story. You can get a pen holder so Bee-Bot can draw. You can get a pusher. And then we have a wide variety of mats to teach a wide variety of subjects and cards to go along with those. So if anybody has any questions at any time, please put them in the chat and we'll try to answer them. I think a lot of you might be familiar with Bee-Bot. They're in school systems around the country. And the reports we get are that children get very excited and are very entranced when they're using Bee-Bots, both in learning coding and in the subject that they're being taught. And what we're going to do now, Luis is going to give us a little lesson in coding the Bee-Bot.
Okay. I have here a Bee-Bot and also a Blue Bot. So I'm going to start with the Bee-Bot.
Would you hold that up, Luis, and show the buttons that I talked about?
Sure.
So those are the controls on the Bee-Bot. You go forward, back, left, and right. And then the little X erases your program, and the double lines is a pause button. So you can incorporate a pause in your program. Okay.
Okay, so in this, for this example, the teacher has decided to use a card mat to teach not only how to code, but also teach something about the solar system. So this is an example. So you can use any kind of images depending on what is the lesson you want to have with the kids. So in this case, this example is let's travel around the solar system using a Bee-Bot. So the first challenge can be, how do you go from the Earth to Saturn? And for that, you need to program the Bee-Bot, or you need to teach the Bee-Bot how to go from the Earth to Saturn. So the kid is going to think about, we can go this way and this way, we can go this way and this way. There are really many ways. So kids are going to make a plan, and then they're going to say, okay, I need to go forward, then the left, then forward, and then forward again. So using the buttons, the kid is going to first to clear the previous program, and then it's going to.
Excuse me, Luis,
Yes.
the steps that we say, you see, the kid has developed a goal, which is to go to Saturn.
Mm-hmm.
And now has to make a plan to accomplish that goal. So you chose the plan to go. Which plan are you using, Luis?
So the plan we are using, in this case, the kid is going to use going forward first, then turn to the left, and then going forward and forward again. So that's the plan.
So there were alternate plans, but this lets the student or the child look at various ways to accomplish a goal and choose one. Then the next step is to implement your solution. So Luis is going to code Bee-Bot to follow his plan.
Okay, so I'm going to, to program the Bee-Bot, I'm going to press forward once, then left, and then 2 times forward. So forward, forward, and then I have the program inside the Bee-Bot, and I'm going to test my program using the green button. So I'm in the Earth, and I'm going to press go. So this is my first challenge. So I hope it's going to work. So good. Maybe
so Luis is a little bit experienced. He knows how to do it. But
That's very good.
if the child doesn't achieve the goal the first time, then your next step is to revise your plan so that you get to the goal. So this is basic problem solving. Set a goal, make a plan, test the plan, revise the plan until you achieve the goal.
Sure, and also teacher can change the environment, so he can put an image here. These are asteroids. So, and then the challenge is different. So how do we go from the Earth to Saturn, avoiding the asteroids? So really, there are many, this is for creativity, many ways to implement lessons using, in this case, solar system, but of course, teacher can use animals, flowers, whatever he believes is a good motivation to teach not only coding, but other things. So the only thing I want to add is that a good way for the kids to plan in advance the program is to use the command cards. So with the command cards, kid can say, okay, I want to plan, so I'm going to, I need to do a first forward, then a left, then forward, and then another forward. So let me check here. So here I have a forward. So this is a way where a kid is really learning how to code, because normally to code you need to have a clear plan, and this is a good way to remember the plan, and if something goes wrong, the kid can really understand what he needs to change, what you need to modify to improve the plan, or to have success with the plan. Any questions?
Children often say, it didn't do what I told it. And what they discover, if you have your plan, it did what you told it, but it didn't do what you wanted it to. So then you have to adjust your plan to fit what you want. And so that's a basic problem solving, but the command cards with the record help make it concrete.
Hey, Luis, this is Palo. Just a quick question. So the mat you're using right now is one a teacher could design their own type of things, correct? And
that's correct.
if they, and so that you could put whatever letters, numbers, whatever types of things you want to use this. In addition, you have maps already created too that they can purchase too, correct?
Yes, that's correct. And Bill is going to show you all the maps that we have. So that's a good question. So
one thing, Luis, why don't you lift up the top plastic on that one? This one's called the card mat, which is a 6x6 grid. It's a blank grid covered with a clear plastic. So the clear plastic holds images in place. So you can, it's easy to put whatever images you might like on the grid and put the plastic down. It makes a very good surface for B-Bot. So it makes it it's a very flexible mat for teaching whatever subject you would like. A lot of teachers tell us they use it for sequencing stories, so that they put images from a story the students might be reading, and then they work through with the B-Bot what comes first and then what comes next. And you could even decorate the B-Bot as the character in the story if you want to.
Great, thank you.
Okay. And if I can share my screen, I'll show you. There we go. I'll show you we have an online emulator for B-Bot. Can everybody see that? And this is, if you want to see the URL, it's up here at the top. It's open and available. But you can practice online, or students can practice online with B-Bot, and this shows all of the mats we offer. The mat that Luis was using is the card mat, which is a 6x6 grid, and then we have some printed mats. For example, there's the alphabet mat, which can be used to teach English, the alphabet. We have a community mat, which is very popular, so B-Bot can help students learn about the community they live in and the different functions. And one of my favorites is the school mat, where the students can teach Bee-Bot about the school. And I'll show you a little example. Where do students want to go? I would say the cafeteria. So here's the cafeteria, and we'll send Bee-Bot there. So you go forward, forward, forward. So we're here, we turn right, go forward, turn left, and go forward. So this shows how it reverses the role of makes the student into the teacher. So instead of teaching the kid how their school day goes, the kid can teach the Bee-Bot, and which is a much more powerful learning experience. And again, you could do sequencing, but each of the mats has a purpose. Here's, for example, the coins mat. You can use Bee-Bot to count to gather coins, and a number line. You can Bee-Bot going forward is adding, going backwards is subtracting. So it's a very easy and concrete way to teach these subjects. Any questions?
Bill, just a clarification. No one's asked this question, but I just want to clarify. So this emulator would be great, for kids at home, or they're sick for the day or whatever, they can kind of whatever. Is there a cost with it? How would they get access to this?
Right now it's open and available.
Okay.
There's no cost. So yes, it works well. During the, we developed the emulator to show our mats.
Yep.
And it does a good job of that. And during the pandemic, when there was a lot of at-home learning, teachers would use Bee-Bot in front of the camera and have the kids follow along with the emulator. So that works well. If also, we want every kid wants a Bee-Bot, no question.
Right.
But if you don't have the resources for that, you can combine working on the computer with the actual programming.
Perfect. Thank you.
Any questions about Bee-Bot? We'll move on to the next robot. We're going from pre-K to 2 to maybe 1 through 3 and 4. Luis, we'll spotlight Luis again.
Okay.
So the next robot is called Bluebot, and that's because this is a Bee-Bot with Bluetooth, and Bluebot works just like Bee-Bot if you use the buttons on the back, but it has a Bluetooth connection, so you can also use another device to control it. So it does, like I said, everything Bee-Bot does, teaches all the same things, plus you're able to introduce the concept of remote control. And again, we have a variety of accessories to support it. The Bee-Bot and the Bluebot share the same form factor and the same scaling, so all the mats work with both of them. And the docking station to recharge works with both of them. And you see here the Hive case. You can store or carry Bee-Bots and Bluebots in a specially designed case that keeps them safe. But the Tactile Reader, which you see there, is a special device to control Bluebot remotely. So you can use the Bluebot and the Tactile Reader. You connect the two together via Bluetooth, and the buttons no longer work on the Bluebot because you are using these tiles to control it. So you write your program on the Tactile Reader and press go there instead of pressing go on the robot. You can also do a similar program with a free app on the iPad or on an Android tablet, and can connect your Bluebot via Bluetooth and control it from there. There's also an app for Chromebooks and PCs and Macs, which I'll show you after we have a live demo of Bluebot.
Hey, Bill, just a quick question back to the maps and stuff like that. Are there different maps for your different products, Bluebot, Bbot, Tuff-Bot, or they're the same mats?
They're the same mats. We have one mat they're the same mats, and they're the same form factor and the same scale. Both of them move in 6-inch increments.
Yeah.
So everything between Bluebot and Bbot are the same. The one thing is, when you remotely control a Bluebot, it can turn 45 degrees. So
Okay.
we have one mat, the baseball mat, which when you face the pitcher, you're facing straight ahead. To run the bases, you need to turn 45 degrees. So that one's designed specifically for Bluebot, but otherwise they're all interchangeable.
Thank you.
And Luis, you can show how Bluebot works in person.
Okay. Okay. I'm going to use this Bluebot. As you can see, it has exactly the same shape and size as the Bbot, but it's transparent. So, but the most important thing is that it has Bluetooth connection. So I'm going to use the Bluetooth connection. So to connect this Bluebot to this tactile reader. So the tactile reader allows the kids to put all the program here step by step. So they just need to put a tile like this. So I'm going to use the same challenge as we had before. So in this case, I only need 4 steps for this demo. So I only need 4 tiles.
I think you have to go a different way because you put the asteroids in the way.
Okay, Bill, I'll take the challenge. So in this case, since I have asteroids here, I need to do first a left. So I will first do a left. Yes, a left, and then I have to go forward. Then so I have to go forward again, and then I have to do a right. So let me. Okay, this is a right. So I'm going to put a command right, and then finally I have to do a forward to get to Saturn. So the lights are, as you are going to see, are very important because it shows the kids what is the step that is running at every moment. So first, I'm going to connect the Bluebot with the tactile reader using the blue button. So let me do that now. I'm pressing the blue button, and the Bluebot should change the eyes to blue. So that shows that it's connected. So let's
push one of the buttons, Luis. When the eyes are blue, the buttons no longer work, and you're using the remote control rather than the buttons. But the buttons do work when the eyes are white, just like a Bbot.
Correct. So now I can only control the Bluebot with the tactile reader. So let's test my program. I hope it will work. And I just need to press the green button here in the tactile reader. There is a green button. So I will do that right now. Okay, so it worked. So this is a very clear way to show you how the Bluebot works, and also how important is, in this case, we're using the tactile reader to have a very good tool to plan the code in advance, and also if something goes wrong, the kid can change, debug, correct the program in a very simple and visual way. So
that's a new concept, which is editing your code.
Right.
So this not only introduces remote control, but also introduces the ability to edit your plan.
Correct.
And
Okay.
you might have noticed as each step is followed by the bot, the red light comes on above the command. So that's another visualization of what's going on. That the blue bot makes an easy transition because the kids are used to using the B-bot with the buttons, and then they're still holding the commands and putting it on the tactile reader. So it makes an easy transition to the concept of remote control. Like I said, besides the tactile reader, you can use a tablet or a computer also with an app, a free app to control the blue bot. Any questions about blue bot? I'll show you the app.
Nope, there doesn't seem to be any questions.
Okay, let me go to the blue bot app. Here's the blue bot app. Similar to the B-bot app, you have the blue bot. I have it here with the Old West mat, and you have the commands. The kids always want to send blue bot to jail. So we'll go forward to, left and forward. It writes out the commands. This starts emphasizing the words and what it means, and you press go. And it highlights each command just like the light. I think my blue bot started a little bit off, but we're going to put him in jail. And then we can erase the command. I can show you, it has extended turns, so you can turn 45 degrees. We'll change the mat here to the card mat. So you can turn 45 degrees. Start introducing the idea of measuring turns. And in addition, if you're using remote control, you can do repeat loops. So we can have, to make a square, you can repeat 4 times forward and right. So here's we're repeating 4 forward and right. And this is another new concept you can do with BlueBot. And you see it rotates through each command back and forth for each of the repeats. So this is a concrete way of showing the kids how the programming is work and how a program loop works. And this is another free app, and it's available for, it's a web app, so it's available for any device that can run a browser. And it also, if you have a BlueBot, you can connect it to the BlueBot and control the BlueBot on the table as you're controlling it on the screen.
Just want to add that I want to add that you can also have the option to program loops with the tactile reader. You just put the code you want the kid to repeat in a loop between these 2 brackets, and then the number of times that the loop needs to be run. So all this program is going to be run 4 times. So this way the kids is going to also have a very visual way of how a loop works, and how they can use loops to do very nice figures in the math. Okay.
Any questions? Okay, Paolo, I think we'll move on to Tuff-Bot.
Great.
Okay, let's go to Tuff-Bot.
So Tuff-Bot is a robot that has oversized wheels and is, as its name says, is tough. And it can go it works fine in a classroom environment, but it can go beyond the classroom, outdoors on the playground, over the grass. It's programmed by, as you see in this bottom right, you see the commands. This one starts off with 45-degree angles. You can go forward and back and turn 45 degrees at a time. So it can be programmed with the buttons using that keypad. In addition, it can be programmed remotely like the Bluebot. You can use the tactile reader, you can use a tablet, or you can use a computer running the web app. And it's pretty tough. It can flip over and keep going. And the wheels, you don't have to pump them up there, but they are oversized enough to generally get through the grass and over gravel and some rough environments. Also, its scale is a bit larger than Bluebot and Bee-Bot, so it goes further with each step. And so that makes that adds to its toughness, in that it can go a good distance, a bigger distance. So we can go and then a really exciting thing about the Tuff-Bot is that it's designed to carry a camera. So you can put a camera on Tuff-Bot, which will capture images or can broadcast them back to you. And so you can see where the robot is going. You combine that with the toughness of the Tuff-Bot, so you can send the robot even to where the kid might not be able to go, under a bush or around a tree, behind things where they can't see. They can send the robot to look for them. In addition to the camera, it has a data logging backpack that it can carry. You see on the right-hand side. So not only can you record visual images of what the robot is seeing, you can record the temperature, the humidity, and the light. And this turns Tuff-Bot into a device like a Mars rover. So if you're studying how robots work in space, this lets you emulate the whole idea of sending a robot where the kid might not be able to go, and gathering information to come back and study and see what the environment is like where the robot went. And this is a new robot. We think we're targeting because it starts with the 45-degree angle buttons. Most kids start learning their angles in 3rd grade, we understand. So we're targeting this 3rd grade and up. But by the time you add a camera and a data logging backpack, it'll fascinate and keep the kids going, we think, up through sixth grade or even into middle school. And because it has a large range, and Luis's table's a little too small for it there for a demo, so we have some he can show you the Tuff-Bot, but we have some videos of it in action. So why don't we show it first? Yeah.
So yeah, this is the Tuff-Bot, and as you can see, these are the buttons, very similar to Bee-Bot and Bluebot, but it has 45-degree angles, as you can see, has lights. Also, it has sensors to avoid obstacles. It has a button for change the speeds. It has 3 speeds and a button to automatically avoid obstacles.
So if you look at the 3 robots, the Bee-Bot is very simple, and each robot adds several new concepts that build on the concepts that the children learned with the previous robot. So this one starts off with angles, and it introduces obstacle avoidance, data collection, etc.
Yes, and the example we want to show you is that we have here a hole where you can put, for example, a camera. So this is a high resolution camera, like a GoPro,
which Eduporium does carry with the
yes.
Tuff-Bot. So
Yes.
they're available at the same time.
Yes. So I'm going to show you a video to demonstrate how this works. So let me share the screen again. Okay. Okay. This is, you're going to see what is the challenge and how the Tuff-Bot works. Here we go. As you can see, seems that the challenge is easy, but really is very, it requires a lot of planning and estimation, how many turns, 45-degree turns, and really try, and is really a complete different set of challenges. And I want to show you how you can use the camera to here. So this is the video that the camera was recording when the Tuff-Bot was moving. So I'm going to run the video so you can see and hear it.
So this is the program from the Tuff-Bot's perspective. So this is what the robot is seeing.
Yes, and I was capturing this video from my iPhone, so it's a very fun and creative way to create challenges for the kids. Any questions?
Okay, and I'm going to share my screen and show you the Tuff-Bot app. So there is an app for Tuff-Bot, which you can run on screen, but it also could control a Tuff-Bot via Bluetooth. And you can write the program. In the app, you can put some barriers in. So I put in some rocks. So if I want to get Tuff-Bot, it can't go through this rock, so I'm going to have to back up. Let's see, if back up twice, turn left, and then I'm going to try and take it to this rock up here, and we'll go forward 3 or 4 times. Let's try that. Oops. Okay, so it went left. I'm going to go forward. Come on. No, I don't know what. We'll try it again. So now let's go forward, forward, forward. I don't know what's happening. You can have, you can add, besides the 45 degrees when you're controlling remotely, I'll show you some additional things you can do. You can add additional turns, add 90 degrees into the mix, and also repeat loops like the BlueBot. Automatic obstacle avoidance is here, and that can be turned on and off in the app or on the actual Tuff-Bot. So let's turn right, forward. There we go. We've woken up again. I think this is my computer is a little bit overloaded because of the webinar, but this does run in a browser, so it's on any device. There's also a tablet app, all of which are free. And this, you can change the speed, move it faster. So it gives you a lot of options, and expands the classroom outdoors. So if you're during the pandemic, I know a lot of classes were meeting outdoors, and this was the perfect solution for that. Any questions? Okay, Paolo.
All right. Well, I want to thank everybody for attending today. I want to thank Louise and Bill for presenting today and doing an overview of their products. I know we at Eduporium have done a review of the different elementary robotic solutions, and Bee-Bot, Terrapin, and their 3 robots are a new partner with us. We're very excited. We think it really fundamentally meets a need in that entry-level kind of robot for kids in elementary school. So what we do want to kind of discuss is we do have a raffle today. thanks to Luis and Bill. And basically, they have graciously agreed to provide one Tuff-Bot, excuse me, to someone who participated today. And the only thing you need to do is send me an email at palo, P-A-L-O, @eduporium.com. Include your name, title, school name, address, email, and phone. And the most important thing is how you would use the Tuff-Bot. And basically, if you do that, we will pick a winner and we'll pass that on to everybody. We are going to send out a copy of the presentation and a copy of any slides or and a video recording if you missed something or you have a friend who missed something. And we're here to answer any other questions before we close out today. We do really want to thank you for coming today. We know that it's a lot, to get out of your day and to come here today. So Luis and Bill, really want to thank you today for coming. So with that, is there any other questions or anything? We'll wait a minute here and see if anything. If not, once again, palo@eduporium.com. Drop us an email and we'll go from there. Thanks, Luis. Thanks, Bill. Appreciate it. Have a great day, everybody. Thank you very much for attending. Bye-bye.
Hello, thank you, Paul. Bye-bye.